Hello everyone, I am V. Mohit Sai from G136 group. In this presentation, I would like to talk about plan of execution of our project expression tracker, that is sentiment analysis for dyslexic kids. In this slide, we will see about what are the main components of the solution. Front end, that is user interface. It is a simple user interface where children interact with games, and admins can also access this interface to monitor progress and analyze results. Middleware, that is Express.js server. It handles the image capture from the game and facilitates communication between the front end and the deep learning model and also with the database. Coming to deep learning model, it analyzes facial expressions in real time to classify emotions. Database, MongoDB, stores user images, session data, and emotional analysis results for review and reporting. Coming to the tech stack that is used in our project. Frontend. In frontend, we are using React.js and WebRTC for webcam access. And in backend, Node.js and Express.js and deep learning model. We are using Python based deep learning model in which we are using deepface library and Flask and image capture and facial landmark detection. And database, we are using MongoDB for real-time updates. Now let us see the communication workflow. Step 1, child plays the game and images are captured. Step 2, images are sent to the server using Express.js. Step 3, deep learning model analyzes the images for emotions. Step 4, analysis results are sent to MongoDB and back to the frontend. Step 5, admin can request reports or access visual insights of data. So this is the pictorial workflow of our project. So let us see what are the underlying data structures in this application. Image data stores paths and image metadata for each child session, and emotion analysis results. The result is in the form of JSON, which holds the details for each recognized emotion. For example, happy 0.75% and sad 0.10%, which is in JSON form. User profiles, basic information on each child, for that is age, ID, and any special needs, and also the session data for personalized tracking. Let us see about database schema and flow. User collection, it stores user profiles and any relevant metadata. Image collection stores image paths and related metadata. Emotion analysis collection stores the JSON output of each emotion analysis and links back to images. This is how our MongoDB structured data looks like. And real-time data flow. Images and analysis data are stored and linked using unique IDs, making it easy to retrieve for later session or reports. Coming to the user roles, we have two users, that is child and admin. Child. The child interacts with the game and he or she plays the game and facial expressions are monitored, and it is a simple game interface, no interaction with analytics. Coming to admin or teachers can access sentiment analysis and performance insights. They can view reports of student performance and emotional state during gameplay. Interfaces that we need to be developed. Game interface. It must be engaging and easy to navigate game interface with automatic image capture. Admin dashboard. Access to reports, analysis, visualization, and option to trigger reanalysis of stored images. Developer console. Backend interface for updating the model and monitoring server health, typically accessed through CLI or admin tools. Datasets used and processing. Pipeline. Image capture is a real-time via webcam that is sent to backend with Express.js. Pre-processing. It is handled by the deepface library in Python. Emotion detection. Deepface classifies the emotions, that is, whether the child is happy, sad, angry, etc. Data storage. Emotion results linked to the game sessions in the database. Processing of the data. Images are passed to deep learning model which analyzes the facial expressions and returns the results to the server, and we can display the results in the front end. Input and output screens. Input screens. We have two input screens. One is for child and other is for admin. Game screen. Interface for children with minimal controls. It automates capturing images to avoid distractions. This is how game screen looks like. And admin input form. It allows admin to configure sessions, select reports, and manage users. So this is admin interface. Output screens. So this is the output screen of our project. The result is in the form of bar graph, and real-time analysis display displays the detected emotion on the admin dashboard after each analysis session, reports and visual insights, visualization of emotional data over time for each child, including average emotions and highest emotion, score spikes, and comparison across the sessions. Let us see the architecture of the project. Architecture overview. So front end. In front end, child interaction takes place. So the child interacts with the game that is developed in JavaScript, which includes features for capturing images during gameplay. So the game captures images of the child's expressions as they play. And middleware, that is Express.js server. So the captured images are sent to a server that is built with Express.js, which stores the images temporarily. So deep learning model that is used for analysis. So the stored images are processed by a deep learning model. It is a Python based model that uses deepface library for analyzing of images, and which analyze the child's expressions to determine the sentiment. And MongoDB. So the database stores both raw images and analysis results, including details about the child's gameplay and the captured expressions. Admin interface. So admin users can request analysis reports which pull data from the database. Report display. Analysis results are displayed in a visual format showing sentimental trends, that is in visual forms like bar graphs. Here are some key business logic of our project. Emotion based feedback. Adjust the game difficulty or show motivational messages if negative emotions are detected. And performance tracking. Scores are based on the both the gameplay performance and emotional stability, that is via facial expression analysis. And admin reports. The periodic reports for teachers highlight emotional trends and learning progress for each student. Here are some sources and references links. So this is a link how to perform face recognition with deepface. So this is the official deepface website for installing the deepface model. So to get an overall view of MERN stack overview, this link could be helpful, and for React.js, this link could be helpful. So the conclusion and the steps that to be initiated. Conclusion. Our project is an integration of real-time facial expression analysis that enhances the educational gaming experiences of dyslexic children. The steps that to be initiated: model refinement, real-world data gathering, broader educational appliances. Thank you.